Okay, following on from my previous video, which was on polynomial long division, we now arrive at something called the factor theorem. The factor theorem is very straightforward. It says if x equals a, for any number a, is a root of f of x equals 0, i.e. if you plug in x is equal to this number into this function and you get 0 out, then x minus a is a factor of f of x. It means that we can divide f of x as polynomial by this factor, and we'll end up with a polynomial of one less order, but with no remainder. Okay, so we're going to use that to our advantage. The converse of this theorem is also true. If x minus a is a factor of f of x, then that means that x equals a is a root. So we can actually use that in our work to check our answers, which is also quite a nice feature of this theorem. Okay, so I've got 3 examples. Here's my first one. Show that x equals minus 2 is a root of this cubic is equal to 0. Then it says to factorise the cubic fully and sketch the curve of y equals this cubic. So in the previous video, we were given what to divide the cubic by, but in this case, we're not. We're going to use the factor theorem to do so. It does say to show that this is a root. So to show that it's a root, I'm going to take x equals minus 2, and I'm going to plug it into this cubic on the left-hand side. So that's going to be 2 times x cubed, but x is minus 2, plus 21 times minus 2 squared, plus 55 times minus 2, plus 42. Now, so you just show that this equals 0. If it equals 0, then it's a root, and I've shown the first part of the question. Just be careful of your signs. Okay, I'll put the brackets in just to make sure that I don't make any sign errors. Very easy to make sign errors, so just be careful. Okay, minus 2 cubed is minus 8, times that by minus 2, that's going to be minus 16. Minus 2 squared is positive 4, times that by 21, I'm going to get plus 84. That's going to be minus 110, and then I've got my plus 42 over there. What I then tend to do is, because it's a show that question, I don't like to say it just equals 0. For this, I would put another step in by combining the positives and combining the negatives. You really want to convince the examiner that you are sure that this does equal 0 and you're not just using facts from the question. So that's going to be 126 in the positive, and 16 plus 110 is 126 in the negative, which then just shows that you really have thought about how this does indeed equal 0. So because it equals 0, then we can conclude that x equals minus 2 is a root. Okay, so that's the first part of the question answered. Now to do the second part of the question, what we're going to do is we're going to apply the factor theorem. So x equals minus 2 is a root. By the factor theorem, this implies that x plus 2 is a factor. Okay, don't forget that we use the minus in there. It's the value that makes this bracket 0. Okay, so x equals minus 2, plug in minus 2 into here, you'll get 0 out. So if x plus 2 is a factor, then what we can do is we can use polynomial long division on this cubic expression here to give us a linear times a quadratic. So stick it in the bus shelter. That's going to be 2x cubed plus 21x squared plus 55x plus 42 divided by x plus 2. Okay, I've done a video on this already, so I'm just going to go through this fairly quickly. What times by x to get to 2x cubed? Well, that's 2x squared. Times that by that, I'm going to get 2x cubed plus 4x squared. Subtract the 2, I get 0 plus 17x squared. Bring my 55x down. What times by x to get to 17x squared? Well, that's 17x. X times 17x is 17x squared. 2 times 17x is 34x. subtract the 2, I'm going to get a 21x and a 0. What do I times by x to get to 21x? Well, that is 21. Times the x plus 2 by the 21, I get 21x plus 42, which gives me a remainder of 0, as I expected, because I know that x plus 2 is a factor, because I've shown that x equals minus 2 is a root. Okay, so that means that this cubic can be written as the linear times the quadratic. Now to sketch it, what I'm going to do is factorise the quadratic as well. So I'm going to factorise this 2x squared plus 17x plus 21. It's going to be a 2x there, an x there. It's probably going to be a 7 and a 3. Yep, if I put a 7 in there and a 3 in there, that gives me 14 plus 3, which is 17. Okay. So all three of my roots are negative. I've got minus 2, minus 1.5, and minus 7. So minus 7, minus 2, minus 1.5. Those are my three roots. Again, doesn't need to be accurate, it is just a sketch. It's a positive cubic because my coefficient of x cubed is positive 2. So it starts low and ends high, and it goes through my y-axis at positive 42, because that's the constant at the end of my cubic. Come up, come down, turn very quickly to go up again, and it's not a great shape actually, that one, but it'll do. 42 minus 3 on 2, minus 2 and minus 7, and that is my sketch done. Okay. That's one application of the factor theorem. Okay, second example is a little bit different, a little bit trickier, and also the division is a little bit trickier as well, so I wanted to draw your attention to that. So given that x equals 2 is a root of this, it should be 0 equals. Given that x equals 2 is a root of 0 equals x cubed plus ax plus 30, find the value of a. So this is a slightly different question. We're now told that it is a root, and we need to find a value of one of the coefficients. This is quite a common style of question. But we're just going to apply the factor theorem. I'm going to apply the factor theorem in a minute. Apologies. We're going to take x equals 2, we're going to plug it into here, and it must satisfy it because it is a root. So we're going to end up with a nice equation with a in it. So I'm going to take my 2, and I'm going to plug it into this cubic. So it's going to be 2 cubed plus a times 2 plus 30, and that must equal 0. So that gives me a nice simple equation with just an a in it. That's going to be 8 plus 2a plus 30 equals 0, which means 2a must equal minus 38, which means a must equal minus 19. Okay, so that is my value of a, and that answers the first part of the question. Second part, fully factorise the cubic and sketch y equals x cubed plus ax plus 30. We now know that a is minus 19, so that would be minus 19x there. So what I'm going to do is I'm going to take my cubic, which is now x cubed minus 19x plus 30, and I've left a giant space there on purpose, because don't forget what I said in the last video, we like to keep everything in columns, so we have a cubic column, a quadratic column, a linear column, and a constant column, but there's no quadratic term in this cubic, but there could still be a quadratic term in a little bit, so we must make room for it. So I'm just going to put in a 0x squared just to make sure I've got all of my columns in place. That's why I wanted this example in here. So now we use the factor theorem. We've shown that x equals 2 is a root, so that means by the factor theorem that x minus 2 is a factor. Okay, x equals 2 is a root, so x minus 2 is a factor. And I do long division on this. X squared, x cubed minus 2x squared, subtract 2x squared, bring the minus 19x down. That's going to be plus 2x. You can see how there's quadratic terms. So we needed that quadratic column in there. That's going to be 2x squared minus 4x. That's going to be a 0 minus 15x. That's going to be minus 15. Bring the 30 down. Minus 15x. And minus 2 times minus 15 is positive 30. Subtract the 2, I get 0. So that is my division there, which means my cubic can be written as x minus 2 multiplied by x squared plus 2x minus 15, and then I can factorise that quadratic into x plus 5, x minus 3. And that allows me then to sketch it very quickly. Okay, I've got roots at -5, 2 and 3. It's going to cross my y-axis at 30. That's the constant here at the end of the cubic. It's going to start low and end high because the coefficient of x cubed is positive. Oh, wow, that's an awful cubic. No, that's a really bad shape. We'll go with it. 2, 3, -5, and this point here is 30. I'll say that's a bit of an awful shape because that bit was a bit too linear for my liking, but it's not horrendous actually. Okay, and that will give you 4 marks in exam. There's no issue with that, but just try and make it as much of a curve as you can. Okay, that answers question 2. Question 3. There's a couple of features in this question which, again, I wanted to draw your attention to, which is why I've popped this question in. This is my final question. So given that x equals -1 and x equals 1 are roots of f of x equals 0, where f of x equals this quartic with 2 unknown coefficients, p and q, it says find the values of p and q. So what I'm going to get now is a pair of simultaneous equations. So I'm going to use the fact that both of these are roots, just like I did in the previous question, when I used that one of them was a root to find one unknown coefficient. I've now got 2 roots, which I know, and I can use that to find my 2 unknown coefficients. Okay, this is kind of very top end kind of questions on a year 12 curriculum. Okay, so let's plug in x is -1. So that's going to be 2 times 1. -7 times -1 is going to be +7. -1 squared, that's just 1, so it's plus p. -1 times q is -q, and then -5 equals 0. So that tells me then that p minus q must equal 5 minus 9, which is -4. So that's one equation which links p and q together. We can now use the other root, which was 1, to give us another equation in p and q, which then we can use those 2 equations to solve simultaneously to find values for p and q. So plug in x is 1, we're going to get 2 minus 7 this time, plus p again, but this time it's going to be plus q, and the -5 is still there. And rearranging that gives us p plus q is going to be 5, plus 7 is 12, minus 2 is 10. That's a pair of simultaneous equations, number of different methods that you could use to solve these, including elimination, substitution. You could even use trial and error, it's that simple. You can use a matrix method, you can use a calculator, whatever, it really doesn't matter. I'm going to subtract one from the other, so it's elimination. So p minus p is 0, q minus q is 2q, and 10 minus -4 is 14. So that tells me then that q is 7, plug it back in, and that gives me that p is 3. Okay, 3 plus 7 is 10, and 3 minus 7 is -4, so that is correct. So that gives me then my quartic, tells me that f of x is equal to 2x to the 4 minus 7x cubed plus px squared, but p is 3, plus qx, but q is 7, minus 5. So that's my f of x now. Now it says to fully factorise f of x and hence sketch the curve. Alright, so I'm going to take this and I'm going to divide it by a known factor of this quartic. And actually I've got 2 known factors. I've got x plus 1 from here, and I've got x minus 1 from here. So because both of those are factors, then the product of those is also a factor. So I'm actually going to end up dividing by a quadratic. Okay, because that's a factor, then that product is a factor. It's like, if I have the number 24, I know that 2 is a factor, and I know that 3 is a factor, therefore 2 times 3 is also a factor. It's that kind of principle. This is the difference of squares, so that's x squared minus 1. Okay, so because x plus 1 and x minus 1 are both factors of this quartic, then that means the product which is x squared minus 1, is also a factor of this quartic. Okay, so that allows me then to take this quartic and divide it by the quadratic, as opposed to dividing it by each of the linears in turn. Okay, because that would involve two long divisions, which is just effort. Okay, 2x to the 4 minus 7x cubed plus 3x squared plus 7x minus 5. I'm going to take that quartic expression and I'm going to divide it by the quadratic x squared minus 1. What times by x squared to get to 2x to the 4? Well, that's 2x squared, so I'll put it in the squared column. That times that gives me 2x to the 4. And again, similar to the previous example, I've now got no cubic term. Okay, because this times this, there's no cubic. But I still need to put it into play. And I'm going to get a minus 2x squared. Okay, like so. And now I subtract the 2. So that subtract that is 0. That subtract that is minus 7x cubed. And that subtract that is plus 5x squared. And I bring down my 7x. What are times by x squared to get to minus 7x cubed? Well, that's minus 7x. X squared times minus 7x is minus 7x cubed. Minus 1 times minus 7x is plus 7x. And once again, there's a term missing, so I'm going to pop in a plus 0x squared. Subtract the 2, that disappears, that becomes 5x squared, that disappears. Bring down my minus 5. And then what do I times by x squared to get to 5x squared? Well, that's plus 5. 5x squared. There's no linear term this time. And then minus 5. Subtract the 2. 0, as promised. So this quartic then can be written as the product of this quadratic and this quadratic. So this allows me then to say that f of x is going to be equal to x plus 1 times x minus 1, which is what this quadratic is factorised. And then we want to factorise this quadratic as well. And we'll end up with 2x minus 5 and x minus 1. Okay, and this brings me then to the final point of this example, which is not in any of my previous examples. And this is the fact that we've got what's called a double root. So we have a double root at x equals 1. So my roots for this quartic are x equals minus 1 from this bracket, a 1 from this bracket, a 5 on 2 from this bracket, and then another 1 from this bracket. It means it's only got 3 roots, but we do refer to the number 1 as what's called a double root. And graphically, what happens at a double root is the curve will just touch the axis at that point. It won't go through the axis at that point. Just to illustrate what I mean, let's just sketch it. So we've got minus 1, that's a single root. We've got 2.5, that's a single root. And then we've got 1, which is a double root. It crosses my y-axis at minus 5, so that's a negative. And it's a positive quartic because the coefficient of x to the 4 is positive 2. So it's going to start high and end high, so it's going to come down from a high number. It's going to go through my first root. It's going to go through my y-intercept. It's then going to come up, but it's not going to go through at 1. It's going to touch the curve at 1 and turn around before turning and going up through my second positive root. So it looks like this. It just touches the curve at 1, and that is the effect of a double root. And that's minus 1. Crosses down here at minus 5, and that's my y-axis, and that over there is my x-axis. And that's my sketch. I'm done. Alright, thank you for watching. I hope you found that useful, and tune in for more videos.